Hello, this and my other YouTube videos are extracted from the History of Man series, currently 6 books published in print, ebook, and most importantly, audiobook. I'm a storyteller, and if you like these video stories, you'll love the History of Man series audiobooks. Great for commuting, or just sitting back and relaxing. And unlike a novel you've read where you know the ending, you can listen to these books on tape more than once. There's so much to learn. Available on Amazon and audible.com, I narrate the audiobooks. And the best part about that is you can listen to these stories without having to look at my stupid face. And with that said, let's get the show on the road. Hello, this is John Bershoff with another episode of History of Man series. Today's subject, Global Warming 101, Part 4. In Global Warming 101, Part 3, we discussed radiometric dating of proxy materials, the avatar, carbon-14, as in carbon dating. This video looks at some of those date-stamped proxy materials in order to reconstruct ancient temperature timelines. You see, carbon is also a proxy material, plain old carbon-12. The higher the temperature around the world, the more normal carbon-12 is shoved into materials that contain carbon, such as carbon dioxide or carbohydrate compounds. So you go to the South Pole Antarctic ice sheet, dress warm because it's cold, and bring some whiskey, for your hot toddy, an Irish drink of whiskey, lemon, hot water, and honey to keep you warm. And then you grab an ice core and date stamp that ice using carbon-14 radiometric dating. So here's your chunk of ice, you grab it, and you date stamp it with carbon-14. But then you look at the amount of normal carbon dioxide, CO2, dissolved in the water right before it froze. Normal carbon-12 in carbon dioxide, not carbon-14. Yes, you use that to date stamp. And yes, carbon dioxide gas does dissolve in water. Gases do that. It then freezes in solution maybe 30,000 years ago, maybe 1,000,000 years ago. And you measure the amount of carbon dioxide dissolved in that ice proxy material. So here's your ice, and you measure the amount of carbon dioxide in that proxy material. It's practically a straight line graph of global temperatures. Higher temperatures, higher amounts of carbon dioxide in the atmosphere, higher levels of carbon dioxide in the ice water right before it froze. Right here, increase in temperature, more carbon dioxide in that ice right at the moment it froze. Now that temperature timeline using carbon dating can take you back 50,000 years to when our ancestors left Africa 50,000 years ago. But other matrix dating can take you back millions of years if you date stamp with, let's say, uranium-238 or uranium-235. Another proxy material used is normal oxygen-16 to non-radioactive oxygen-18 in water itself or in carbon dioxide. So you first date stamp the ice core, perhaps using carbon-14. You then measure the ratio of oxygen-16 to oxygen-18 in the water molecule H2O. The ratio of oxygen-16 to oxygen-18 remains unchanged because oxygen-18 is not radioactive, despite having 2 extra neutrons. So here's your oxygen-16. You got your 8 protons, normal oxygen-16, 8 protons, 8 neutrons in the nucleus, and 8 electrons doing whatever electrons do. But the higher the temperature, you end up with a couple extra neutrons in that nucleus. So here's your oxygen-18. You got 8 protons, you got 10 neutrons, and you got 8 electrons doing whatever they do. But the point is that oxygen-18 is not radioactive. And the warmer the temperature, the more oxygen-18 is made. And the more oxygen-18 is made, the more of it that gets shoved into water or carbon dioxide. Again, it's practically a straight line curve. Higher temperatures, the more of the oxygen in water is oxygen-18. The more oxygen and carbon dioxide dissolved in that water is also oxygen-18. You can use uranium-235 or uranium-238 to date stamp a really deep South Pole ice core to 500 million years old, which would take you back to the Cambrian explosion, when life on Earth really, really blossomed, and all major phyla that exist today evolved during the Cambrian explosion. And no, it wasn't a bomb going off. It was an explosion of life. Heat drove vegetation, which drove an explosion of life. It was an Earth hothouse with global temperatures averaging 72 degrees Fahrenheit. In comparison, average global temperatures today are supposed to be 57 degrees Fahrenheit. Of course, when it got really hot during the Cambrian explosion, it triggered the Permian extinction 250 million years ago, when 90 to 96% of all species, some genus, and a few families went extinct. Stifling heat does that. You know, when Earth formed, it grabbed from the cosmos more than its fair share of water. But new water on Earth is being made all the time, as is carbon dioxide. They are being used all the time, and they're being made all the time. It balances out. Photosynthesis uses water and carbon dioxide and sunlight to make those 6 carbon sugars. And then the Krebs cycle uses those 6 carbon sugars to downgrade them to 4 carbon to extract ATP energy. But that carbon backbone is also used in bone and plants. It's everywhere. Carbon, oxygen, 16, and water, oxygen, 16 to 18 ratio. So here's your photosynthesis. You got your carbon dioxide. That oxygen can be 16 or 18. You got your water. That oxygen could be 16 or 18. And with photosynthesis, you get your carbohydrate structures. That oxygen can be 16 or 18, plus it releases oxygen, 16 or 18. But the point is, this carbohydrate structure can then be pushed into through the Krebs cycle, or not through the Krebs cycle, just through normal metabolism, into bone and plants and fossils and coral rings and so on. And you date stamp them, and you look at the ratio of oxygen 16 to oxygen 18 in the carbohydrate of that backbone. Simple chemistry tells us that the more heat, the more oxygen 18 gets shoved into water molecules and into carbon dioxide gases, when they rather not. And it's not radioactive. And then the carb to bone to plants, even rocks, can have this oxygen ratio. Now, other proxy materials include pollen count. Pollen? Well, yeah, the hotter the atmosphere is, the happier plants are, to a point. The more pollen is produced, the more pollen dissolves in water that then freezes, and you can measure the pollen count of various ice cores to get an idea what the temperature was when that ice froze. The ratio of magnesium in calcium and the ratio of strontium in calcium in rock can also be used. You see, rock has oxygen in it. The silicates have oxygen in it, so you can look at 16, 18. But the other thing you can look at are like the calcites, calcium carbonate, because when it's hotter, magnesium or strontium can get into that structure, can replace the calcium in the carbonate, magnesium carbonate or strontium carbonate. The higher the temperature, the more magnesium and strontium is in that calcite. And again, it's almost like a direct measurement. Global warming data from NASA data, says it took 10,000 years from the end of the last ice age, which was 20,000 years ago, for Earth to warm from 47 degrees to 57 degrees 10,000 years ago. That's a rate of 1 degree per 1,000 years. So here we are at the end of the last ice age, 20,000 years ago, the temperature was 47 degrees. 10,000 years ago, it had warmed up to 57 degrees. That's 1 degree Fahrenheit per 1,000 years. Remember that because it's important, the rate at which the Earth warmed after the last ice age. Because currently, it has taken just 50 years for Earth to go from 57 degrees Fahrenheit to 58.55 degrees Fahrenheit, or close to that. So it's gone up over 1.5 degrees Fahrenheit in just 50 years, where here it took 1,000 years just to go up 1 degree. The same is true as atmospheric carbon dioxide levels. When Moses was wandering the desert and Socrates was lecturing on the steps of the Pantheon, carbon dioxide levels were at a cushy 280 parts per million. That is our planet's sweet spot in between ice ages, 280 parts per million. The current carbon dioxide level is 420 parts per million. It's a huge increase in just 50 years. These abnormal climatic changes will be further fleshed out in Global Warming 101, Part 5. On our planet, global temperature of 57 degrees Fahrenheit and atmospheric carbon dioxide of 280 parts per million is our sweet spot. And they may be more than just pals. They may be inextricably connected. One moves as the other moves. Earth's atmosphere is actually 78% nitrogen, N2, 21% oxygen, O2, 0.93% argon, and only 0.04% carbon dioxide. Well, that's a small amount of carbon dioxide. How could it possibly affect global temperatures? Well, those gases, like nitrogen, but also oxygen and argon, they're not great greenhouse gases. What they do is they keep water from evaporating into the cosmos. Take Mars. It practically is our twin, except it has a very thin atmosphere. And whatever water Mars once had, well, it went poof into the cosmos. So those gases keep water in. But carbon dioxide is different. It serves a different purpose. It is an exquisitely ideal greenhouse gas. Carbon dioxide is the top shelf greenhouse gas. It absorbs solar energy, it allows solar energy to pass through, and it vibrates, pushing back heat off the Earth that wants to leave Earth into the cosmos. It does all three of those things, and you don't need much carbon dioxide to form its greenhouse business. Carbon dioxide is the classic greenhouse gas. Dump more into the atmosphere, it retains more solar heat. The reflective abilities of the atmosphere increases, and with it, the temperature of the planet increases. Carbon dioxide levels using proxy materials like those ice cores, where atmospheric carbon dioxide is reflected in carbon dioxide dissolved in water that then freezes, lets us have an idea of parts per million. Now, where does the carbon dioxide come from besides animals exhaling it? Well, normal carbon dioxide comes from oceans that release carbon dioxide into the air as part of the carbon cycle, as well as decaying organic material on land. But human activity that leads to carbon dioxide emissions, burning coal, oil, natural gas, pushes carbon dioxide into the atmosphere. And scientists make a distinction between normal atmospheric carbon dioxide and what they now call anthropogenic carbon dioxide sources, which means human activity besides breathing. Anthropogenic carbon dioxide is human activity, burning coal, oil, natural gas. In Global Warming 101, Part 5, we'll focus on rate of increase in global temperature in the past 50 years, from 37 degrees to 38.5 degrees or even higher. And we'll focus on global atmospheric carbon dioxide levels from 280 parts per million to the current about 420 parts per million. It is the rate of increase, like Vince Vaughn, Vegas, baby. It's the rate of increase, baby. I hope you enjoyed this episode of History of Man series. I got 6 books out. This is the first one. It's a style of writing called jumping off. I have a baseline, which is medicine and science, and I jump off into art and music and philosophy and astronomy and geology, geography, sports. I come back to the baseline and jump off again and come back. I keep the baseline story going. It's maybe not a style of writing for everybody, but most people who read these and listen to these books, they learn something with the turn of every page. I certainly did. The books are available in print, e-Kindle, and audiobook, where yours truly does the narrating. I hope you enjoyed this. Check out part 5 of Global Warming 101, and be well and have a good day. Thank you.